So today's lesson is on definite integrals. We're also going to learn how to integrate with our TN Inspire calculator. The integration we've done so far are called indefinite integrals. Those have a family of answers that needs a constant, a plus c at the end. And we have variables. Today we're going to learn about a definite integral. A definite integral, the answer is going to be a constant. A definite integral is going to be a number for an answer. Not an equation, no plus the candy. This is so important that they have that fundamental theorem of calculus. When they start naming things like that, you can know that's an important idea for the AP exam and beyond, that this is a big concept. There are two parts to the fundamental theorem of calculus. This is one part. And the other part will be done in Unit 6. So, indefinite is what we've done before. Definite is what we're doing today. How can you tell the difference between the two? A definite integral has bounds, an upper and a lower bound. So when you have your integration sign, you'll have a number on top and a number on the bottom. Usually the number on bottom is smaller than on top, but it doesn't have to be. But most of the time, A is smaller than B, and it's integrating from A to B. So, another way of thinking of integration, we did this over the summer, is the idea of, yes?
Would that be like a restriction? Or?
Yeah, well, no, think of it as a bound. Rather, you can think of it as a restriction, but I like the word bound, that it's bounded on the left and right, and you're thinking of it from left to right, just that area, what the integration is. And another way to think of integration, we did this over the summer, is thinking of it as area under a curve. And that was like a long time ago, but you're going to come back to that idea again and again. Area under a curve. And if the area is above the x-axis, the area is positive. And if the area is below, it's negative. And if you have a combination, you have to combine the positive and the negative and come up with an answer together with that. We're also going to learn how to do it without graphing, with graphing, and with our calculator. And again, it's important. Fundamental theorem of calculus. So let's start with number one. Number one says to use, and they had a TI-84, so it's like from 1984. So we have an Inspire that is actually beautiful. If there's one thing that's way more beautiful than the calculator we used before, it's integration. It is so user-friendly. So can you turn on your calculator, please? And we're going to integrate number one using our calculator. So turn it on. I need you to get to the scratch pad, or the part where you can calculate. I even know why that little symbol's there. But I'm going to teach you from the beginning how to do it. But can you get to that screen on your calculator? So not the graph. When you turn it on, it usually gives you a choice to graph or calculate. So go to the calculate. Press the menu button. Go to calculus. You can also press the number 4. And then go over, and then obviously go to integral, right? Number 3. Now, when you press that, you're going to see a beautiful template. Do you see that? And all you have to do is fill in the empty boxes. Did I do? What's wrong?
There's a shortcut.
Oh, there's a shortcut. Let's do it this way, and then Jesus is going to teach us a shortcut for the number 2.
We're going to do it, I guess, with their pencils as well? Or?
We're going to learn how to do it with our calculator and by hand. Yes, with our pencils. Both will be with our pencils. But one is going to be using the calculator and one is by hand. Right now we're learning, can we use the calculator to integrate? So for number 1 in the example, what number is the lower bound? Okay, what's the upper bound? And can you move the cursor to fill in the boxes? So negative 3 is the lower bound. The upper bound is 1. Move the cursor. And then what are we integrating is x cubed. So type in x cubed. Move the cursor over. Subtract 6x. You don't need to put in parentheses. The computer assumes that. That's all together. In fact, it puts it together, right? With parentheses. Again, it's a beautiful template. And then we're integrating with respect to what letter? X. And then press enter. Now, if I want that answer, and if it's like a square root, we can always press Control and Enter to find the decimal. But it's a nice answer. What's the answer there? 4. Okay, we're going to do number 2. Jesus is going to teach us a shortcut to get to the integration sign. Go ahead, Jesus. what do I do?
Oh, press the button next to the book.
Press the button next to the book. So the one on the left here? Is that what you're saying? This one right here? Right beside the 9?
Yeah.
Okay, press that. And that gives you also a whole different template, right? Of all kinds of different, well, where is it? There it is. It gives you all kinds of options. Which one is the option we want? And then you can move. See how it's in blue or shaded? You can then move. I'm not sure if this is necessarily quicker, but it might be. But you can move it to integration. But the nice thing about that button is it gives you all kinds of options, right? Including, what did I just highlight there? Absolute value. So it's a quick way to get to absolute value too. So thank you, Jesus. We're going to go there. We're going to press enter. And there's another way of getting to the same thing. We need to be comfortable with all kinds of different ways, right? To be able to get to that. So thank you. So here we go. Can you fill in again? The bottom. So in this case, the bottom is negative root x. The square root is right above the x squared. So control x squared. 6, move the cursor. A control x squared is the square root. That's 6. Move the cursor. Inside is going to be, again, x cubed. Subtract 6x. And then we're integrating with respect to x. And so what does that tell you? The answer is what?
0.
Good. Do you notice the upper and lower bound are the exact same number? And that it integrated to 0. What does that communicate? It means the area above was equal to the area below. That also communicates that this is an odd function. When the area above equals exactly the area below, that's an indicator to know it's an odd function. So that's why the answer is 0. One more time. Let's use for number 3 that new button that Jesus taught us. Can you type that in, please? And can you integrate with your calculator? If at a point the bell rings, I will continue this video during my prep, and it will be uploaded for you to continue this lesson without me. All right, so I'm going to press that button. I'm going to go integration. My upper and lower bound again is -5 to -5. Inside is the absolute value. We're going to press that same button, but this time we're going to go to the absolute value and press enter. And then I'm going to type in x cubed minus 6x. Oh, I pressed the wrong minus. I didn't mean the little negative sign. It's subtract. This is what I needed. All right, in respect to, you're integrating with respect to what variable? Dx. Enter. Oh, it went too far. Go over. There it is. Enter. Yes.
You forgot
Oh, I didn't do x cubed. Let's go back. Sorry, I typed it and it had that stupid little negative thing again. How could I not get rid of it? I'm going to do it again. I'm going to integrate it. If you press Control Escape, it allows you to edit it. So Control Escape allows you to edit it, which I needed to. And then Exponent 3, so that's a handy skill to have. So if you press Control and then the Escape button, it allows you to edit quickly what was before if you made a mistake like I did. Hey, all right. So how can I write that as a decimal? Control Enter. And I don't know why it gives you a caution sign, but it is 198.5.
No, if you click on the sign, it says that it's on version 2.
Huh?
If you click on the caution, it says results obtained using our
Oh, okay. In the other one, it didn't do that, right? It's fine. The answer is 198.5. All right. In number 4, it's saying the same thing. Use the math menu, whatever. It's an old calculator. We just did that question. Same answer. Don't worry about what's on the right there. That's with an old calculator. So we just recognized how to use our calculator, right? Did you get the link I sent you that Jesus got? I tried. And that when you have time to go through, they're like little video tutorials, right? To teach you how to use it. So that's awesome. I'm learning too. It's a new calculator for me over the last few weeks too. So, and you guys are digital natives. I grew up with a black and white TV. Use the idea, I did, of signed area. I know, I'm sorry. So, I was like 10 years old when we got a color TV, so it wasn't like my whole life. So, I'm going to graph this. How can I... Yeah, that's right. That is. I like that show. So, how can I graph this to understand how to integrate using area rather than with my calculator? So, do you see 2x minus 1? When 2x minus 1 equals 0, that creates a vertex. So at what x value do we have a vertex? So can you find where 1/2 is? And that's going to be a vertex. When I plug in 0, that's my lower bound. When you plug in 0, the answer is -1, and the absolute value of -1 is 1. There it is. When I plug in the other bound, which is 3, 2 times 3 is 6. 6 take away 1 is 5, and the absolute value of 5 is 5. So, go all the way to 3, and then go to 5. I want you to know we graphed this absolute value function from 0 to 3, right? The absolute value has a vertex. To find the vertex, yes. When you plug in 0, the absolute value of -1 is +1. But can you see the absolute value, V? The endpoints are easy. The vertex we have to think about. Now, to do the integration with area, do you see 2 triangles here? One triangle's here, and the other triangle is here. We find the area of the 2 triangles together, and we can integrate. Absolute value is not capable in terms of algebra. If you have a calculator, it'll do it for you. But the algebra part of it is a headache. Graphing, when you see absolute value, is how you would integrate. What's the area of a triangle? So, if I'm integrating, the answer is going to be, what's the first triangle? The height of it? 1. And the base is 1/2. Right? That's 1/2. What's the second triangle? What's the height?
5.
And the base? 2.5. Correct? So your answer is right here. We could simplify that. I'm not going to do it right now. If we simplified it, it is 13/2. But that's like the least of my worries. Do you see the area of a triangle? What would happen if one of the areas was below? The area that was below would be subtracting rather than be adding. So one way to integrate is to draw it and find the area between the function and the x-axis. All right, turn the page. Hey. Oh, is my screen cutting it off? I'm sorry. On the video, you won't see the cutoff of the screen. For sometimes my LCD projector, it cuts off what's actually on the computer. I can't figure it out because some days I turn it on and it actually mirrors it exactly, and other days it decides, the right side's going to be cut off just a little bit. Okay, turn the page. We will not finish it all in 2 minutes, but I'll do the next one. And as I said, I'll talk to you over the video, and you can watch the video of what we didn't do today. It says, set up a definite integral which could be used to find the area from here to here. So how do I find the area using integration? So I'm going to raise this up so that it's not such a headache. We can now see it all. So to find area on the curve, we're going to integrate. What's the bounds of what we're integrating? I'm integrating from what number to what number? 0 to 2. What's the equation? It's given to us. 2x squared. And that's dx, because we're integrating with respect to x. That integration matches the area under the curve. That's a skill we're going to practice more and more, finding that area. Number 7. I got more time. That was quick. It says, discovering the fundamental theorem of calculus. If I asked you to find the integration from 0 to 5 of that derivative, what you would do is you would find the area under the curve. What shape is this to find the area? And what's the size of the rectangle? That's not half. This right here is 5. And then the height is 3. It's 5 times 3, which is 15. If I said write an equation for that horizontal line, you would just write down the derivative is y equals 3, but it's a derivative, so it's f prime at x equals 3. A horizontal line, the equation is just y equals 3. But it's a derivative, so it's the derivative equals 3. If you integrate that, what would you get? Makes me all sad. You'd be 3x, and then you'd plug in 1 and make it equal to 4. And we're going to continue number 7 on the video. These short days. Dang it. All right. I'll catch you later.